Hi again, I'm back with some more word problems, and I wanted to cover a couple of examples that tend to throw students off quite a bit. Let's just look at one here. And this particular example has to do with work. But you're going to see it's actually pretty much the same as the mixture problem that we did last time. Okay. So let's suppose we got two people, Fred and Sally. And so Fred, let's say he splits a cord of wood in 4 days. And you might be asking, well, what in the heck is a cord of wood? Well, it's a lot of wood, basically. You can look it up. It's a stack of wood. I think it's like 4 feet by 4 feet by 8 feet or something. But anyway, it's a lot of wood, and you got to chop it up with an axe before you can burn it. So Fred's going to split one of those cords of wood in 4 days. A lot of work to do. Well, let's suppose Sally splits a cord of wood in maybe 2 days. Sally's a much more accomplished wood splitter. What we want to know is how long will it take them to split that cord of wood working together. Okay. So this is going to come back to that same type of equation here, where we have the work rate times the time is going to be equal to the total work done. That's the important equation here for us. But more important than the equation itself is, again, how the units work in here. So the work rate, well, that's going to be on cords per day as the units for that. So of course time should be given in days. The number of cords divided by some number of days, hopefully 1 day for a unit rate. That should equal the number of cords that are totally split. Okay. Now here's going to be kind of weird because we're actually not going to have a system. Because really what we're looking for is how long it's going to take for them to split the cord working together. That's what we want to set our variable to be. So we'll let x be the amount of time they work together. So again, I like tables. They help me keep everything organized. So I'm going to set everything up in a table with 3 columns. The work rate, multiply that by the time, and that's going to be equal to the total work. Now one thing that we might want to consider, and this is where it usually throws people off, is this work rate and the units on them. See, Fred splits 1 cord of wood in 4 days. So 1 cord divided by 4 days. And keep in mind that units are actually factors. So there's a multiplication in between this 1 and this cord and this 4 and these days. So we could rewrite this, just splitting up this multiplication of fractions as 1/4 times cords per day. Right? If we can split 1 cord in 4 days, that means he's going to split 1/4 of a cord every single day. So for Fred, his work rate is going to be 1/4 cord per day. Now the amount of time that he's going to be working, well, he's going to be working for X days. He's not going to quit early, neither is Sally. So if we multiply the work rate times the time, we'll get the total amount of work that Fred does. 1/4 times X, and of course the days are going to cancel. So this is in cords of wood. Similarly, for Sally, well, she splits 1 cord of wood in 2 days, so that means she's going to split 1/2 cord of wood in 1 day. So she's working at a rate of 1/2 cord per day. Again, she's working the same amount of time that Fred does, X days, and if we multiply these two together, days cancel and we have 1/2 X cords of wood that Sally's going to split in that amount of time. Now working together, well, let's see here. Working together, they're going to split 1 whole cord of wood, and it's going to take them X days. So 1 cord of wood in X days would be a rate of 1/X cords per day. Again, together they're going to be working for X days. Now if we multiply these together, we get the total amount of work done. But keep in mind they're going to be splitting 1 whole cord of wood. But that makes sense here because the X on the bottom will cancel with the X on top. Days and days will cancel. And we're left with, of course, total amount of work of 1 cord of wood. And now we see in this last column an actual equation here. Because the total work that Fred does plus the total work that Sally does is going to be the total work that they do together. So Fred does 1/4 X cord of wood plus Sally splits 1/2 X cord of wood. That's going to equal 1 cord. Or just 1/4 X plus 1/2 X is equal to 1. There's an equation, pretty simple. We can solve it for X, and that is exactly the amount of time they're going to be working together. And I'll just leave that as an exercise.